matrix here will be 4, 1, 6, 3, 3, 2, -1, -1, and 1.
Yes.
Yes.
Okay. To that, I'd have to find my determinants. I'd have to take care of all the chutes before I look at all the ladders.
Yes.
Okay. Now, that's having to multiply 3 numbers together. Now, isn't it easier to multiply 2 numbers together?
Yes.
Okay. Let me show you how to do that via using 2 numbers. The way I start this is I'm going to start with the first entry, the top left. In that top left, notice how it's going, it touches this column, or excuse me, that row and that column. Everybody see that?
Yes. Yep.
What are the 4 numbers it doesn't touch?
3, 2, -1, 1.
So I take 4 times the determinant of 3, 2, -1, and 1. Okay? Doing a determinant of a 2 by 2, you can do in your head. 3 minus -2, 5. So you get 4 times 5, which is 20. Okay with that? Now, the next time I do the same idea, I'm going to put a minus sign, and I'm going to change to the second number. The second number is in the first column, and it's not touching, it touches this one, so which 2 isn't it touching?
1, 6, -1, 1.
So it's not touching the, so I put a 3, 1, 6, -1, and 1, and I do that one. Once again, a 2 by 2 determinant, pretty simple to work through. We get 1 minus -6, 7. So I get minus 3 times 7, so I get minus 21 here. You okay with that? I do it again. Now here's the trick. Your signs for these things always goes plus, minus, plus. That's the only thing you have to remember. Bless you.
Bless you.
The only little weirdness of it you have to remember. And I move my circle to the bottom one, and now that bottom one is still in that first column, but it's touching the bottom row now. So I'm going to work with the top 4 numbers. So I wind up with -1 times the determinant of 1, 6, 3, 2.
Do you have to write them in that exact order?
Yeah, it has to be placed
So
in that.
when it's, you had it like
Bless you.
the 3, 3, 2, and it's crossing out, do you have to write it so it just condenses down?
Yes, it's 1, 6, -1, 1. That has to, it flows that pattern. So now you get 2 minus -18, so it's,
No, yeah, it's
2 minus 18, so it's -16. -1 times -16. So I get plus 16, and I get 15 for my determinant. A lot of people think that it does look like it's more work to do, but in essence, you're doing less mental math. Now, I know I showed you that. Did you try it at all?
No,
Oh,
I forgot how you explained it.
Oh, okay. I thought you would have. I thought if I showed it, you would have tried it.
Yeah.
Because I had Hannah Hickey try. I showed it to her yesterday. She did it. She said, "It's so easy." It's another means to do it. It's not that you have to. I literally figured that I saw that method yesterday for the first time ever, and I thought it was pretty cool that you can break it down into smaller chunks so you can do more of the mental math. Because I know if you're like me, multiplying 2 numbers together is a little less taxing on my old brain than 3 numbers.
We're gonna get the dumb calculators though, right?
Yes.
Okay, thank God, 'cause I'm really bad at multiplying.
Same here. But other than that, solving systems wasn't all that bad, right?
No.
Good. Let's continue on then. But first,
There's more.
Yeah.
Hey, Janice.
you guys all did your homework, whatever.
I mean, I didn't, but I'll say.
Are you kidding me? Extra complex periods from
Oh, I
the
remember
I'm gonna give you
that.
credit for it. I'm gonna give you credit for it.
Wait, that was the girl that I got the last strikeout of the game, wasn't it? 44?
Yeah.
And she struck out looking, and it was hilarious. It was the last pitch of her entire season. She struck out looking. It was hilarious.
She could have gone down swinging.
Yeah,
she
it
could
could've
have
been
tried.
because
She had a really decent pitch, swung at a bad
Wonderful
pitch, struck out.
song. Tom Petty and the Heartbreakers, Swinging.
Okay.
game was hilarious. I was dying. I laughed so hard.
Clay, you're such a mean person.
It was hilarious. She had the entire thing of her team season in her hands, and she struck out.
They were losing 5-0. We couldn't have done anything. It was so
There's a thing called comebacks.
Don't call it a comeback. I've been here for years.
She kind of started yelling, and then she's like, stop yelling.
Should I go get it? There's the announcements.
What?
This room is done by technology.
That sounds like something that's big.
All right, let's do something different. We only have a couple more new things to look at, and then we're going to be done. I know you're really, really excited. Today, what we're going to talk about is something really.
She's in the media center. She'll be here. Oh yeah, that's really favorite entire sophomore class was. Yep.
Anyway, identities and inverse matrices. What we're going to do here today is talk about what an identity matrix is, as well as how do you solve for what's called an identity, and how we use an inverse matrix. The way that we're going to use these is to solve matrix equations. In the past couple of days, we've done stuff where you've multiplied two matrices together, a 2x2 times a 2x2, resulted in a 2x2. You write it down twice. Well, what we're going to do is matrix A times some other matrix equals matrix B. What's that other matrix? By using an inverse, we're going to be able to find that. Once it's not going to be a horrible, scary math, it's just kind of a weird process. You do the process once or twice, it's not a big deal. So first thing I want to do is talk about what's called an identity. When you're dealing with an identity matrix, when we're looking at just basic 2x2s or 3x3s, will be the matrix that has ones on the largest chute, on the largest downward diagonal. That's how that's going to work for an identity. In this class, it's called I for identity.
I thought I did while you're imaginary. Did you say that one?
I'm sorry, what was that?
What did you say?
The ones are always going to be on the downward diagonal, the largest downward diagonal. So if it's a 2x2, you'll have two of them here. If it's 3x3, you'll have three of them. And they're going everything else in there, every other entry of the matrix is always going to be a 0. It's called I because it's called an identity. It's a capital I. So don't confuse it with the imaginary here. Now, the reason that we have these identity matrices, you're not going to use them tremendously in this class, nor would you use them in high school. If any of you guys wind up taking any engineering stuff, you might have to take an upper level algebra course where you're going to see vectors and things like that, where you're going to have to use identities more often. They help to solve systems. It's another way of solving a system. What I want you guys to think of is multiplication identity properties. For example, think of it like this. 3 times what is 1? 1/3. 1/3. 3 times 1/3 is 1. Therefore, 1/3 is the multiplicative inverse of 3. Okay? What we're going to do is work with matrices. All right?
Big word. Like, it's not like, this is math.
No, it really isn't. We're determinants bad on a 2x2. Chutes and ladders. Well, if we look at it kind of straight on, is it all right? Or is it more of a skew? All right, me too. What we're talking about is the following. Matrix A times some other matrix is matrix B. And just like a second ago, we multiplied the left-hand side and the right-hand side by the multiplicative inverse of 3. we multiply it by 1/3. Now, another way of writing that, if I wanted to solve that equation, we multiply both sides by 1/3. Or I can write it like this. Isn't that also the inverse? 3 to the negative 1? Isn't that the inverse of 3?
Yeah.
Means the same thing.
That's about the math.
I'm getting that. So if I do that to both sides, x is going to equal the inverse of 3 times 6. The inverse of 3 is 1/3. It's just another way of writing it.
So x equals 2.
X is still going to equal 2.
But I think it's true.
You can, but I wanted you to see this though. Like this, the way of writing it, the nomenclature, means the same thing as 3 to the negative 1 means the same thing as 1/3. Means the same. That's all it is. Because we've done negative exponents before where it's just 1 over. What we're going to do here is I'm going to move this value by doing the following property. Multiplying both sides by what's called an inverse. When you multiply these two values together, you get what's called the identity matrix, that 1's on the diagonal. And whenever you multiply something by 1, does it change it? All we're doing here is a weird version of multiplying. That's it. Instead of flipping a fraction, we're going to flip some, what are these called? Matrices. That's about it. The only rule I have to remind you guys of is when you multiply both sides by an inverse, the inverse matrix always goes first. Okay? Because remember, when you multiply matrices, it's not commutative. The commutative property of multiplication doesn't occur within matrices. It won't work. Matrix A times matrix B will not be the same as B times A. Yeah. So it doesn't work. So you have to do it this way. So as long as you remember to put the inverse one first, you're going to be fine. So let's look at how you find an inverse. Hi, guys!
So the reason for that
Don't miss me,
formula
Friday,
is
girl.
the inverse of A times A. You basically cancel it out in the text.
It leaves you one times. Okay. So what we're going to do is we're going to look at, first of all, figuring out how you find the inverse of a matrix. I'm pretty sure I'm going to stick with just 2x2s on these. Okay? Now, in order to find the inverse of a matrix, we start with our initial matrix. The initial one here is 3, 1, 4, 2, going from rows across. The first thing you always want to do is find the determinant of the original matrix. Well, determinant of 2x2, shoots, subtract the ladders. 6 minus 4. Okay? So the rule will become to find the inverse of a matrix. First thing we do is take 1 over the determinant of the original matrix. So we found the determinant. We 1 over that. To that, I'm going to move some stuff around within the original matrix. Your original matrix was A, B, C, and D. 4 entries. Okay? When I use the inverse matrix, my A to the negative 1 power, is going to equal 1 over the determinant times exchange the shoot, change the signs of the ladder. Exchange-o, change-o.
I'm not using that.
He's a math magician.
If you ever say that again, I will leave this class.
Exchange-o, change-o.
I'm going to the
Follow
office.
through.
I can.
Can't follow through.
Fancy.
Clay.
What? She didn't follow through.
So,
It's a funny word.
It's an insult. At least I didn't say something really mean. I could have said like quitter.
Hey, Clay, you're stupid.
fight! Sorry.
I really would.
Well, I didn't know you had favorite music.
Exchange-o,
Change up.
Change-o. Switch the chute, change the ladder. Switch the chute, change. We're getting it. We're not done yet. We're finding the inverse. Now the last step here is to then just distribute into the matrix. Because this is now just a scalar multiple. So you wind up with 1, -1/2, -2, and 3/2. So the inverse matrix would be that. I'm going to show you what's happening here. What's happening here, Emma, is that eventually we're going to have this matrix A times some other matrix X is going to equal matrix B. We're going to be able to solve for this matrix X by finding the inverse of matrix A times matrix B. And it's going to give us that other matrix. That's what we're doing.
Are they very long problems?
No, I'm going to try and keep it. I'm going to keep it by 2 by 2s.
2 by 2s?
Yeah, because you have to do matrix multiplication then. Yes, ma'am.
So we found what's it called, the determinant.
Yep.
And then that's why it's 1/2.
Yes, it's 1 over the determinant as a scalar multiple of the exchange-o change-o. It's more fun to say exchange-o change-o. This is the inverse of A is this. Like I said, the usefulness of this is to be able to solve this. Yes, ma'am.
Do you care if we use decimals or fractions?
I would prefer the fractions. I think it's actually change. Oh.
I think that's dumb.
Otherwise, it's changeo. All right. So let's look at another one.
It's a star. Exchange-o.
Presto, problemo. So I'm just going to go right into why we use it, how we use it.
How much time did you sit down to shrink that and put a little star over it and call it exchange-o change-o?
It doesn't take very long.
It just seems like it'd be a lot of work. Make a star.
This conversation has taken longer than that. Anyway, so what? Chance. You can't do matrix division. You have to use matrix multiplication by using the inverse property. So what we have to do here to solve this matrix X is, remember, this is A times X equals B. Matrix X is going to equal the inverse of A times matrix B. So what we have to figure out is the inverse. So when you find the inverse of A, yes, ma'am. What do you, yes, sir?
Does it have to do with any like log functions? 'Cause we
You're just
have-
thinking that because of the axes.
Yeah.
No, it has nothing to do with logs.
What do you mean the axis? Because AX is.
It's just matrix A, matrix B, and that's all it is. It's just how they're writing it out. They're not logs. No worries. So your inverse is going to equal 1 over the determinant of A times the exchange-o change-o.
I wish.
The determinant, 4 minus 1.
Doing work.
Yes.
3.
What? Yes. I was doing the answer already. 4 minus 3 is 1. I did say 3.
Yeah.
You were listening, Val, so air 5 for listening.
Wait, I'm so confused now. You said 2 different.
I'm going to start over. Ready?
Yes.
4 minus 3.
God dang
Yes.
Can you repeat
This
that?
many.
That.
Show him.
No. Exchange, change.
I'm seceding.
No taxation without representation. So, the determinant of matrix A happens to be a nice number. It's 1. Okay? Now we do the exchange-o, change-o.
Exchange-o, change-o.
One.
Shots fired.
So after I have exchanged the chute and changed the ladder, is that better?
No.
I get the matrix of 1, 1, 3, 4, because the scalar multiple is 1. I don't have to multiply in all those 4 entries. So now, I'm going to get matrix X is going to equal the inverse of A times B. Well, the inverse of A is 1, 1, 3, 4. And matrix B was, a little help?
8, negative 5, negative 6, 3.
Yep. So now you just have to multiply those 2 out. And it's a 2 by 2, so it's not going to be that bad. When you multiply a 2 by 2 times a 2 by 2, what do you get?
A 2 by 2.
A 2 by 2. So how many times you write down the first matrix?
Twice.
Oh, I remember. I think that is.
Even Cody is here, he's still
And then fill them in. 8, negative 6, negative 5, 3.
There's one thing I get away from this class, it'll be exchange-o, change-o.
What's 8 minus 6?
2.
Negative 5 plus 3.
Negative
24 minus 24.
8. I'll take it. I'll find
Negative 15.
Sounded so serious.
Negative 15 plus 12. There's your answer.
Wait, X was a matrix this whole time?
Yeah. I said matrix A times matrix X will give you matrix B.
I thought we had to like determine that or something. If I can answer. I thought we'd have to like use the determinant of X to figure out what X
No.
Okay.
Nope. So, like I said, it's not a lot of hard math. It just takes a little bit of time.
Yeah. He's not passing those.
So, let me show you another one.
Wait, is this work for 3 libraries too?
What do you say to do that? Don't cry. It's just math. Are you going to succeed with Lily? It was a simple.
The way I'm starting my own math.
So take a look at what I did differently now.
We have to add. We have to add.
Correct. Take a look at what this is. If I write it out in terms of labeling the matrices, I have matrix A times matrix X minus matrix B is matrix C. Think about your order of operations you have to use to move things around. What would you have to do? Oh, I'll give you guys a second to write it out first. Sorry. I didn't mean to get ahead of you. Okay.
I was playing with sawdust tiles and wood shop today. I finished my clock. Sterling created it. So I was all
Ah, I see what you did there.
Can they knocked my clock off the shelf, and Dylan, it's not my fault. I put it on the top shelf. Someone grabbed the clamp, knocked it off. And the little trim, you know the trim is supposed to stay on the back?
Yeah.
Wait, the glue pried loose, so it was all angled, and he took off points back. Someone knocked my clock off.
You could like die, you could die like.
I guess I don't have time for that.
Mr. Riveri made that job work.
Get like the bars, you can get like a little bar, or
Now, everybody agree here, if I do this in terms of A, X, B's, and C's, I'm going to have AX is going to equal C plus B. Matrix-wise, right? Addition doesn't matter because you're just adding the entries. In multiplication, yes, it makes a big difference. And then you have to take X will equal the inverse of A times whatever C plus B was, okay? Now, when you're doing the inverses here, the inverse matrix always has to go first, otherwise it won't work, okay? Like I said, the commutative property of multiplication does not work for matrices. So now we just have to start moving stuff around. What's 3 times 2? What's 2 times 3? Commutative property means the order in which you multiply doesn't matter.
Oh.
So let me move this over to a clean one here. And I'm going to get 4, 6, -3, -2, x has to equal, I'm adding this over, 3, 7, 13, and 9. We okay with that?
So just add them straight like that?
Yep. They match entry for entry. Now we got to find our inverse of A. Our inverse of A is going to equal 1 over the determinant of A. Well, the determinant of A is going to be -8 minus -18. So it is 10. 1/10. I take that and I'm going to multiply it by my exchange the values along
Exchange-o, change-o.
Yeah, it's much easier to say. -2 and 4, and change the signs going up the chute, or up the ladder. And now I just have to distribute. Okay. When I distribute this, I'm going to get -1/5, 3/10, -3/5, and 2/5. That is my inverse matrix. To that inverse matrix, I'm obviously going to multiply it by 3, 7, 13, and 9. I know there are fractions. There are going to be quite a few fractions when you have inverse matrices. But you have the calculator, okay? The dummy calculators still have the fraction bar. Use the alpha y equals to create the fraction. It's still going to work out just fine, okay? So when you put all this together, obviously it's a 2 by 2 times a 2 by 2, which means it's going to equal a
2 by 2.
which means sometimes you write down the first matrix.
Twice.
So you get -1/5, -3/5, 3/10, 2/5. Write it twice. Oops. And then I fill them in. 3, 13, and then 9. One thing, it's habit for me a lot of times to write it in terms of a simplified fraction each time. But you might notice if you don't do that, you're automatically going to get common denominators. So if you have a fraction and you're putting your inverse in, you don't have to simplify the inverse one. I could have left it as -2/10, because when I'm adding those together, I can do it quicker. Does that make sense? Unless you're using your calculator, it doesn't matter. And it's just a matter of putting all those things in your calculator. So you get -3/5, which is -6/10, and 39/10. So the first one is 33/10. -9/5, and 26 fifths. It's 15 over 5, so it's 3.
And that one came out anyway.
Why? You. I thought the first, I thought the mini matrix was 4 seconds.
Yo, we're not going
Yeah.
back.
Oh, crap.
Ah.
Oh, no, it wasn't, because I added, thank you. I added this over. Yes. Sorry, don't scare me like that.
That was hilarious.
Sorry.
Fear was real.
The fear was real. So we have 14, negative 14 tenths, 27 tenths, 7 tenths? 13 tenths, sorry. And then negative 21 plus 18 is negative 3. You will get ugly things. It's going to happen. They take a little bit of time to walk through. The arithmetic isn't difficult. It just takes time. That's why I only have 2 of these for you to do this week.
And I only wrote R.
Isn't it negative?
Which one?
The last one.
Oh, yeah.
Okay. I also have the extra credit for you.
Oh, I saw it.
It is.
Extra credit costs, you have to 90 points.
It is a 6x6 Kramer's rule problem.
Yo, guys, we all.
It
better be a lot of points.
Guys, I haven't made a point value. I haven't even made an answer key for it yet, so I don't know.
Well, just give us a range.
More than 1, less than 100.
What round?
Hey guys, at least we're not getting fractions of points.
Mr. Murphy.
Clay said it right there. At least it's not a fraction of a point.
Mr. Murphy.
When did
Yes,
you
ma'am.
do?
What
Monday.
category will it go in the grade?
Keep past that bit.
Ooh, that's the real question.
I don't know.
Go to the test and make it like I don't want to waste my time.
We're all in her.
Okay, so
He's like talking. No.
That's really important.
That's a lot.
I will say this. Obviously, we're using this a Kramer's rule. You're always going to do one more determinant than you do the dimension.
7.
So you're going to have to do 7 total determinants to solve this. You'll have to find the coefficient matrix determinant and then the column matrix shifted around. It's not easy. Show all your work. I will give you this bit of advice. The solutions.
procrastinate.
Don't procrastinate. The solutions are clean.
They should already.
No.
Wait, so are fractions?
That would be amazing. You did it
No.
wrong.
Clean, I'm talking, they're integer value. You'll have positives and negatives, but you can have a 0. You never know.
One sheet per matrix.
I don't know.
When is it?
Monday. Homework-wise, it's just 2 problems out of this section. It's
Vigorous.
4, 4. It's not 28 and 30.
That's what Hannah wrote on the board.
I don't think it was 28 and 30. I think it did.
Hannah wrote 28, 30 board.
No, it's 25 and 30.
Useless Hannah.
25 and 30.
Useless Hannah. Probably missed me retrieving it.
It's 25 and 30. It's one problem where it's a straight inverse, and it's a problem where you have to move a matrix first.
It's not freezing here today.
It is for here.
Put it in each column.
Put it here and put it there.
Those are kids in the chat.
He'd never met anyone before he got to that last weekend, and he just took off. He figured it out right away and just started going.
If I wasn't last year, we were on like Canada, we were trying to do a conversion and spend it in
No, he took off, he was going back and forth all of this, this was fine. And then he let Ryan in there, and Ryan loved it. So Connor just, he's really, really proud of himself, and all he wants me to go buy him a kayak.
You should.
Hold on, time.
I want a kayak. It's just funny. I don't.
Hey, it's spelled the same backwards.
You have to buy a kayak. I just
I will suggest that you, for the 6x6, for the 6x6, it might not be a bad idea to find the determinant for each of those values on a separate sheet of paper. Just to keep things straight as you're walking through. Okay? Change up.
Yeah, it's so catchy. And it makes color go bonkers. Bonkers? Yeah, I say bonkers, Jennifer.